I'd like to show you how to calculate the transition probabilities for a Bigram hidden Markov model. I will denote them like this. This will be the probability that we encounter a determiner given that we have the beginning of the sentence before. So you will have Q0. That is the beginning of the sentence, and we also will have a QF for final. That will be at the end of the sentence. And of course, it's maybe a little bit confusing, but we will encounter Q0 first and then the determiner, so that's maybe a little bit confusing that we denote it the other way around. And the probability we will write down like this. Well, let's see how many sentence beginnings we have. We have 1, 2, 3. So this one will give us the denominator, which is 3. And let's see how many times we've got a determiner here. That is 1, 2, and here we have something else. So in this case we have 2 determiner, and this gives us the upper number. In this case we have when we are at the beginning of the sentence, we have a probability of 2/3 that we will encounter a determiner as next. So let's see what the next probabilities are. Well, let's just go like this. Now we have a determiner, and we encounter a noun, and let's see what probability they have. Well, the determiner, sorry, I want to see if I use the right color. Now we have the determiner in the denominator, and we have, well, we need to count all determiners. So we have 1, 2, 3, 4 determiner. And let's see how many of them are followed by a noun. We have 1, 2, 3, 4. So all 4 are followed by a noun. And this gives us a probability of 1. The next probability, that's where we are here, we have a noun. And it's followed by a verb. So let's see how probable that is. Let's first take the number of our nouns, which is 1, 2, 3, 4, 5, 6. Well, I didn't count this before because they don't follow a determiner. Now let's see how many verbs there are. We have 1, this follows a noun, 2, and 3. So the probability when we have a noun and to encounter a verb as next is 1/2. Next probability, well, here we have a verb which is followed by a determiner. Let's see how many verbs there are at all. 1, 2, 3. And now we need the number of determiner, which is that follow verbs. So we have 1. Here's something else, here's something else, so we just stay at 1. So I calculate this one, this one, this one. Now determiner given noun given determiner, we already calculate that. Now we are here. We didn't calculate yet the probability that we encounter a punctuation, given that we encountered a noun. Let's see what are the numbers for nouns. We have 1, 2, 3, 4, 5, 6 nouns. And we have in general 1, 2, 3 puncts, and they all follow nouns. So we have a probability here of 3, 6, which is 1/2. And after the punct, we have the end of the word. Here, here, and here. And as you can easily see, every time we have a punct, we have the end of the sentence behind. So the probability that we encounter the end of the sentence, given that we encountered a punct, is based on this data 1 or 3/3. Well, the next one is beginning of the sentence and determiner. That's what I calculate here. Noun given determiner. That's what I calculated here. This one I already calculated, but this one I didn't calculate yet. So we want to find the probability that we encounter a P, given that we encountered a verb. And the probability for a verb is 1, 2, 3. And the probability for P, well, it follows 1 time the verb, so it's 1/3. And the next probability, we have a P given, and we want to calculate the probability that it is followed by a determiner. And the P we've only got 1 time, while the determiner, well, it's the only case and it is followed by a determiner, so we get a 1/1, which is a probability of 1. Then we have a given determiner and it's followed by a noun, and the noun is followed by a punct. That's what we already calculated. Then, well, this is what we didn't calculate yet. We want to calculate the probability that we encounter a noun given the beginning of the sentence. The beginning of the sentence is, well, we have 3 beginnings of the sentence because we have 3 sentences, and only 1 time it's followed by a noun, so that gives us 1/3. Then this is what we calculate yet. Verb noun, that is a combination I didn't calculate yet. So we have a verb given and it is followed by a noun. So we want to calculate the probability that we encounter a noun given a verb. And the probability for verbs is 1, 2, 3. And the probability for the noun, well, it's only one case where the verb is followed by a noun, so this gives us 1/3. And then we have the noun followed by a punct, followed by a word end, which we already calculated. So as you can see, if we have the same states given, for example, verbs, they have to add up to 1. So we have here a verb with 1/3, and here a verb with 1/3, and we have here a verb with 1/3. So, and they add up to 1. So, but what we have to consider now is all other probabilities that we don't have encountered in this test set. And to make sure that we get them all, we write something like all others. So all other probabilities are equal to 0 because we didn't encounter them in the tests in the training set. And that's how we calculated the transition probabilities.